Hi everyone, thank you for joining. Today we have very exciting webinar today. So I will go into details how we can build on top of FAssets and with FAssets. And a couple of weeks ago we had in Twitter poll where we asked community like what they would like to see, what kind of solution we try to build ourselves to showcase FAssets, the developer tooling, what we have, all of that good stuff. And the community voted that they want to see a multi-chain payment portal. And we took our time and actually stress tested our developer tooling and everything what I showed today. It's open source, so you can go ahead and use. All the guides are on our dev hub, but I will go into details step by step, so don't worry about that. And bear in mind that this session will be very developer focused. Most of the time, I will go into code, explain, and yeah, like if you have any questions, then ask in channel that you're watching, because we are streaming this session to multiple channels. And yeah, so this is FAssets. But bear in mind that we will also use other Flare enshrined protocols, like especially FDC, Flare Data Connector. And yeah, let's get it started. And before we start, at the end, we have Q&A, where you can fill the questionnaire and you can win some nice merch. And next week, our team members will have the lucky winners who will get the merch. But for that QR code, where you can fill the questionnaire, you need to stick to the end. And today's agenda, just three main topics, but the biggest one, of course, is live code. And we reiterate what is FAssets, but very quickly, if you want to go into deeper this topic, we have previous recordings, so please check those, where I went over what is FAssets, what are the steps of FAssets, and so forth. But I will explain briefly once again. Then we have live code demo. So I will show the code, how we can implement FAssets, how we can make payments, all the actions, and all that good stuff. And in the end, there will be a Q&A section. So please stick to the topic. I will try to answer those questions after this session. But once you have a question, please put it in the chat and we can process it later. So what are FAssets? Essentially, FAssets are XRP or any non-smart contract token representation on Flare network, and that is ERC20 token. So basically, you take XRP, then there is minting process. You mint from XRP, FXRP, which stands for Flare XRP. Then you get the ERC20 token, and then basically you can build or use in any type of applications you want, starting with DEXs, lending, borrow, and so forth, and some other activities. And Flare is connected to other EVM networks, so basically you can bridge this token to other networks as well. And after you want to get your original asset, which is in this case XRP, what we're talking about today, then you go over redemption process. So basically you take FXRP, Flare XRP, and you redeem back to XRP network. So that is essentially how FAsset works. There are multiple players in an FAsset system. For instance, main ones are agents who mint assets, and they have they keep their collateral. It's over collateralized bridge. So basically there is an agent part, and then there is a pool part where you as users also can dedicate your funds and you get rewards. And besides that, there are also challengers who challenge all the transactions. So basically all the transactions are tested if they are correct, or someone wants to do something which is not out of ordinary. And there are liquidators. So if agents do something bad, or they want to steal funds, they will be liquidated or penalized by liquidators or challengers. So basically, all the transactions are being validated to be correct. And underneath FAssets, there are Flare and Shrine protocols, which is FTSO, Flare Time Series Oracle. So that is how we can get prices, XRP price. And FDC, Flare Data Connector. So Flare Data Connector comes in handy when we need to check if payment on XRP has happened. For instance, you mint XRP, you send funds to agent XRP address, and using Flare Data Connector, this fact can be proven that, hey, you paid to agent. Or in redemption process, agent has to send back your XRP. And that also will be proven with Flare Data Connector. But we will go into all the details in the code. So yeah, let's go into the code. And this presentation will be shared later, all the links, but the code is here under our GitHub profile. So I will open VS Code, and we can go over step by step. But before that, I will bring in how this application looks. And it is quite a simple application, but there are multiple steps. And this is meant for developers who want to integrate FAssets or build on top of FAssets. And there are multiple things, in my opinion, very important, where you what you need to learn how to develop it. So first one, in my opinion, is settings. There are a bunch of settings, but I will not go into all of them. All those settings can be looked in our dev guide under operational parameters. But the main things, in my opinion, for this application, for minting, redemption, and also transferring XRP tokens, are these. So I group them in contract addresses. So main being asset manager controller. So for each asset is asset manager controller. So for XRP is this one, and this is this data comes from chain. And don't worry, we will look into the code how this is being done. Second is XRP token address, so that is ERC20 token, and then there are a bunch of other parameters. For instance, asset decimals, minting decimals, like what's the smallest unit, and so forth. And that is very important when you do calculations. So this comes from settings. You get these values from chain, so don't hard code these settings. Many of those basically won't change at all, but don't hard code something, because that can be bad in future. Then there are some minting settings. So what's the lot size? So I can remind that FAsset system works with lots. So basically, in this case, 10 XRP is one lot. So you cannot mint or redeem like 15 XRP. So basically, it works in lots. So it's much easier math, and also arrange collateral. Then there are reservation fee. So once you want to mint, there are fees which goes to agent. Then there are redemption fee and very important, not the least one, agent owner registry, which holds information about all the agents, what are agent names, their descriptions, icons, and so forth. So let's go to the code. So here I have the code opened. It's a Next.js application. So a couple of things I try to describe in README, but we will not go over all the README. But before we jump into all the components, then I want to explain that in this example we are using our Flare periphery package, which is Flare smart contracts periphery contract artifacts. So this package basically has JSON files with all Flare contract descriptions, and using these files, so you can, let's say we want to check out asset manager. So here is a description, what's the asset manager interface. And most likely you have seen, if you are working with Hardhat, Foundry, or whatever, you have seen these artifacts, on build time. And using these files, what we did in this example, we used VM, that is another developer tooling, and with that we generated API type TypeScript generated file. So that is actually this file. So it uses WAGMI. So if you have some experience with WAGMI, then you might see this familiar. But if you don't worry. So it has all the interfaces in TypeScript format, and also nice addition, it has some hooks as well here defined in this file. So for instance, how to write we have write function, write hooks to reserve collateral, which we will look a bit later. So this is very nice if you are working with React. So React hooks are a very nice addition, and it has all the type safety. It's I would say it's very nice, so you don't type wrong functions or something. So, and this example is very React focused. So of course, out of these artifacts, you can generate any types that you want for any language. Let it be Rust, I don't know, for iOS, Swift, and so forth. So these are JSON files which describe what are the interfaces. So that is very important for settings. And let's briefly check settings code. So we have here components, and let's start with settings component. So settings component, there are a bunch of imports describing the UI, but that's not so much important. And we have also here links to developer hub. So how to read settings, what are operational parameters. So that's very nice thing. So we can, copy those from here and check the guides in details. What are being used behind the scenes, And to read settings, we are using this hook, asset manager hook, and this hook basically gets the asset manager address, and as all the Flare protocols or protocol contracts, you need to use Flare contracts registry, So we have guide how to do that here. And inside, we also have a library where all the products are listed very with easy the access by having network, then products, and then what's the product or protocol, let's say, or smart contract. Actually, that's more correct said. In this case, we are getting asset manager, and yeah, we need to get the address using the MetaMask provider. Once we get that, we set the asset manager. So that is at startup, we need to get the address. And the next one is this specific hook. So what it does, it calls the function name get settings using asset manager, and it returns all the data back. And that is saved in this settings parameter. So that is the React hook, how we get asset manager settings. And this is done using type safety. So if we type it wrongly, then immediately we see that something is wrong, and we need to fix that one. So that is very nice to working with types, and everything is type safe, so we don't need to worry. And if you hover here, we see all the function names here as well. So that is how we get settings. That is in struct, and also after that we present in this nice way. So next one is I will go step by step. What we can do with FAssets is, okay, we understand what is FAssets. We have XRP funds. Now we want to mint, and minting consists of multiple steps. So first one is select agent that you want to use, and this is demo is using our Coston 2 test network, so it's not using live network. So this is only for testing purposes. That is hard coded. And after that, we specify how many lots we want to mint. And once we have that information, here it shows like how much XRP will be minted. So in this case, one lot is 10 XRP. And what's the reservation fee in native currency? So that is very important as well. And also, what's the agent fee? So agent fee goes to agent from the original asset, so that is 1%. And once we execute that, I will sign that transaction. We get information that collateral was reserved. So basically, we tell the agent, hey, reserve collateral one lot, and we are going to go over minting process. So here is information what we need to use and make the XRP payment. So that is out of the scope for this demo, but basically next step would be to go to XRP network. In this case, we're using test XRP network, and to make the payment. And very important is that we need to put the payment reference and to pay to which address, what's the amount, and reservation ID is just for you to remember. But let's go over code. How are we going to do that? So I will close this, and that is mint component. So here are a bunch of imports, not that important, but here is a very interesting one, and that is that we are importing from this generated file, which we using to generate ABI types for WAGMI and VM toolings. So here we have the agent owner registry ABI, asset manager ABI, and also hook to reserve collateral. So remember, we checked this hook. This is very nice because you don't need to type even the function name. It has already React hooks that we can use. And we will check later how we are going to use it. And these two are just ABI types that you have seen before. Then a bunch of things like checking form validations and so forth. But here is the reservation fee hook that how can we get the reservation fee. And let's go into details how we can get that. Here we have the function calculate reservation fee. And what it does behind the scenes is it executes the collateral reservation fee function with asset manager. And again, if we type wrongly this function, it has all the type safety. And what it does, it gives reservation fee, which is also a FAsset parameter, but don't hard code this because that can change. So you need to get this information from chain. So so that is how we get the reservation fee, and we're using use effect React hook. So basically, that is run on. Well, once we have asset manager, we have lots and agent vault. And then we have a function to get, current fee. So that is needed because that, rate can change at transaction time. So basically, when we execute transaction, we need to ask that information again. Then the important things are here. So that is, we have all the links or all the guides for reference. So once you check this code, all the main information is here. And what we do here is we get we have a place where to store available agents, but how to get agents, let's look at this here. So how can we get the agents is, again, we use asset manager. So that is actually asset manager behind the scenes is daemon proxy, where are multiple facets, but you don't need to worry about all these facets. You execute with function names. And the function is get available agents detail list. Detail list gives a bunch of other information. A bunch of other information like fee, collateral ratio, and available lots. So that is very important in this example because we are filtering out all the agents that don't have lots available, because otherwise the list can be quite long. And again, we have type safety here. If we type wrong this function, immediately editor yells at us. Oops. And we need to pass two parameters, but in this example, we are passing index from 0 to 10. So these are parameters, or you can loop over some other way. But in this example, that was sufficient. And yeah, so that all of that we are saving in available agents, and also it has loading status. Then we have a reserve collateral function, And remember, we discussed this hook that we imported here, and behind the scenes it calls asset manager reserve collateral. That's it, what the hook does. So nothing very very sophisticated or very very tricky. And you need to pass a couple of things to this function. But for that, let's look it a bit later. So here we have hook to wait for transaction come back and to have a receipt. And we will look into details why it is very important. So here we're processing some settings at startup, but that's not so important in this case. Yeah, here we are getting the agents at startup, so that is very important. And here, remember I told about agent owner registry, and here we're getting the agent owner registry API and getting the agent name. And once again, if we type wrongly, then it yells that the function name was not correct. And here is very important thing what we need to bear in mind. FAsset system relies on transaction logs very heavily, so it stores important information. For instance, once we reserved collateral, this information came back from transaction log, and we need to parse that. And that goes into events, and in this case, that is collateral reserve event. And don't worry, we have again guides about what are the events, so you can check under FAssets and FAssets reference, and then there are asset manager events. And all the explanation is here, and you can read that was emitted when Minter has reserved collateral. So that so once we parse that, we show that information on screen. And yeah, to be honest, that's it in this case. Minting function. When we call execute this mint, what it does behind the scenes is that it checks like if it's connected using MetaMask. In this demo, we don't have very sophisticated like wallet checking mechanisms. You need to connect MetaMask before. That was out of the scope. So we're getting the current fee. Remember, we need to get the current fee at transaction time to be completely precise and store it in big integer. Then we get the selected agent because we need to get the agent fee. We are not using executor. For those who don't know, executor can basically, when you mint or redeem, they act as they do it for you, so they prove these transactions are okay. But that is out of the scope for this case. But for developers who are working to build wallet, for instance, or lending borrowing, where your users will bridge XRP, they don't need to specifically know about FAsset system. You need to be act as executor. But don't worry, we have guides, we have explanation on our dev hub what is executor. But in this case, we are not using. So basically, we will disregard this case. And we're calling reserve collateral, a bunch of things. And here's the reserve collateral function called. And these are the parameters. We need to pass the what's the asset manager address, and arguments. So arguments are agent vault address, how many lots. So that goes this agent vault, how many lots. Then what's the agent fee? So we need to we can get that from here when we get the agent detailed list and executor. But in this case, that is zero address. So basically, the system will disregard that. And very important, we need to send the fee in native token chain. So that we're passing as value. So that is WAGMI React way how to call function, and that's it. A bunch of checking the errors and handling errors, and here is UI part, which is not so important. So that is the first component, minting, very important. But basically, now we have reserved collateral. We make the XRP payment, which is out of the scope for this demo. And next one is prove that our XRP payment has happened. And that is very important step. We will not go wait for that, but for instance, we have this. I have this transaction from before where I paid XRP to agent to mint, and that is using Flare data connector. And Flare data connector goes to XRP chain. They check, hey, okay, this payment has happened with that specific reference. So basically, that reference is tied to our reservation, to FXRP reservation, collateral reservation transaction. And I will not go into details of FDC or Flare data connector, but what it does is that it has the round. So round is roughly 90 seconds. Then the the validators will go and check from XRP that this transaction has happened, and then the round ends, and you can get the proof, which is in Merkle tree. So I know it's very technical, but this is the hash that about all these facts, and this comes very important later. So I will go briefly over attestation component, what we saw. So we have links here that you can check the FDC guides, how to like what are the main contracts. So we're using FDC contracts hook. Then we're writing to FDC hub to request the attestation. So that's very important. We also have a link to that one. Then we are checking if when we get the transaction back, what's the round ID, all that. And for that, we have very good guides on our Dev Hub, which also has been explained before in this webinar series. So for learning more, please check those recordings or Dev Hub, how Flare data connector works. But basically what it does, it is one of the Flare enshrined Oracle protocols. It proves that something has happened or hasn't happened. And hasn't happened, we'll check a bit later. So once it does its job, it confirms that everything has happened, and so we can move to the next step. Let's check if we have something here to talk about. Error handling, my main attestation. Yeah, all the steps are here. I will not go into details, otherwise it's too much content. And then next step, when we have the attestation ready, so FDC has said, yes, that payment has happened, you paid to agent, we can go ahead and execute the reservation. remember we had reservation ID. We also had the FDC round ID and XRP transaction ID. So all those three components we have, and we can execute the minting. So we have some things from before, but that won't work. But I will go into the code because these collateral reservation has already been executed, so you cannot execute another time. And execute code behind the scenes here. Form validation. Here we have links, so you can read more about execute minting function. So that's the thing being called. And FTC stuff, getting the asset manager, and this is very important. So here comes the the meat of this component, and that is execute minting wrapped hook, and that is calling execute minting behind the scenes with asset manager. That's simply as it is, and we will check a bit later what we need to pass there. So again, we're processing the transaction to get the logs. We'll check what are the logs. So that is main minting process. So we execute minting process. So what we do here. So at first we get the payment proof. How to get that? Again, I will not go into details, but we use the data availability layer. What it is and why it's needed, you can check in one of the previous recordings. But basically, it provides the validity proofs. So about the fact that payment has happened, and that is very important to prove. The finish minting execute minting function. And so we retrieve the proof. We have the proof, and that's where FDC has finished their job. And also important that it verifies that payment has happened. So basically, it verifies that this proof is correct. But that is also done by FAsset system. And here is execute minting. The main function that we are calling with asset manager address. And what are the arguments? Arguments are miracle proof, so that we get from the proof here. When we got the proof from data availability layer, we also verified that is correct. And this data comes from data availability layer, from Flare data connector. And here is information about this transaction and a bunch of other things, like what was the source address hash and so forth. So I will not go over all of these parameters, but they describe the FDC information, what is needed for FAssets to validate and execute the meeting, to finish the meeting. So basically, you provide this information to FAsset system that, hey, I made this payment on XRP. And also, very, very important, you need to pass collateral reservation ID. So you have the proof. What's the reservation ID? So the FAsset system can go ahead and execute the minting. And here is very important step, because we are going and decoding the transaction logs. So that is the two important logs from minting, execute minting transaction are minting executed. So that is event when a minter has successfully paid underlying funds in time and received the FAsset. And very important second one is redemption ticket created. So you get a redemption ticket. So that is ticket ID that you need to use when you want to redeem back to XRP. So those two events are very important that you need to, parse from execute minting transaction. So basically, minting execute, all good. You can go and use your XRP, and information how can you go back to XRP funds. So those are two logs that are very important. And here is UI part, but that is not important. That is out of the scope for this this webinar. So now we have seen the mintings, how we can mint XRP. So we have XRP, we reserve collateral with specific agent, we send these funds on XRP chain. Then we use Flare data connector to prove this payment to this agent has happened with this specific reference. So that is very important that you need to reference transactions on Flare chain to XRP. So that is passed in XRP payment. Then we use FDC to verify, make attestation that this payment has happened on XRP chain. And after that, we have this information, we go ahead and execute the minting, and FAsset system tells, all good, you get your FXRP, and here's information how you can redeem back to XRP. So now we have minting behind us. Let's go into what we can do with FXRP. So FXRP is ERC20 token. So here we have very simple view to send FXRP, which is ERC20 token. But very important thing is how to get FXRP address. That comes from Asset Manager. So let's go again to code. Bunch of form stuff, import, and here we're checking the FXRP balance hook. So that might be interesting because, but it actually uses ERC20 ABI behind the scenes, which is already included in VM if you are using VM developer tooling with React application. And also we have a guide here how to get FXRP address. So we have all the information here in front of you. And we're using balance of function. So if you are familiar with ERC20 standard, then that might be very familiar for you. So this is how we get the FXRP balance. We just hidden that away in React hook. Then we have the transfer contract. Transfer function hook. So that comes in handy a bit later. So we're using use write contract hook from VM. Here we're handling errors, handle successful transfer. We're checking that everything is fine. But here is the transfer function when we call transfer. So we can send, for instance, one FXRP. And here we see that this transaction was confirmed and it was successfully sent. So what it does behind the scenes is that it gets the asset decimals, because that's very important to calculate correctly amount in FXRP, because it uses a specific number of decimals, and it calls transfer using the address which comes from settings. Remember, FXRP ERC20 token address comes from asset manager, and that is included in settings. So for that we need just settings FAsset, not all the settings struct, but we can see, here, and execute with ERC20 API. Remember, in the beginning we had settings page, so basically this is the address that we can go and check on, Block Explorer. That's the XRP token. So this is how transfer works behind the scenes. So now we have seen how we can mint, how we can get XRP, what can we do with it. We can transfer around, that is ERC20 token, and you all know that on top of ERC20 you can build any type of thing. So that is representation of XRP on Flare chain, on EVM chain. It can be used in smart contracts in any type of decentralized applications. Okay, you had your DeFi journey. You used in various applications, and now you want to get back your original XRP funds. And that is using redeem functionality, and that is a bit more complicated component. So we'll take a bit of time to explain that. So for that we need XRP ledger address where we want to redeem back, and how many lots. Again, important that FAsset system works with lots. One lot is 10 FXRP. Here is information what's the redemption fee that comes from chain, and then what the amount XRP will be redeemed, and this fee is deducted from XRP value. So very important information here. And when we redeem this, like one lot, it executes function, then it gets back the redemption requested event, and also immediately it wants to create a Flare data connector payment non-existence attestation. So what it is that in specific time frame, which is in this case 15 minutes, so that comes from FAsset settings, so 15 minutes, and in that time frame the agent needs to send your underlying funds, XRP funds, and after that, if agent hasn't paid that these funds to you, you can go ahead and say to the ask Flare data connector to prove in this time frame with this specific payment reference which ties to redemption event, this payment has not happened. Basically, hey, I haven't received my funds. And then you can prove to FAsset system that this redemption has defaulted, and that means that you get as user funds from agent collateral. So that is the safeguard system that agent collateral is being used to pay to user. So user is never losing their funds with this system. So this is how it works behind the scenes. But yeah, we have the payment window is still ongoing. So let's go and check the code. And last time what we had. Again, we are importing from generated which was ABI types, TypeScript types, asset manager, and FDC functionality. Here we have a bunch of React states, but that is not important. So here we're getting asset manager, FAsset manager, and here we have FXRP balance, what we actually had in previous example in transfer, and FDC functionality that it creates the attestation that this payment has not happened in this specific time frame. And important stuff what you saw in the beginning was redemption requested event. Bear in mind that in this demo we are processing the first log, but there can be one or multiple events. So for instance, if you are redeeming a lot of lots, those lots are splitted to multiple agents, so that these events can be multiple. But this demo we are processing the first one for to make it a bit simpler. So that is redemption requested. Here we don't have the link, but I will add it afterwards. Here we have redemption requested event, and it says that is event is emitted when redeemer starts the redemption process. And it has a lot of information, like what was the agent Volt who is redeeming to you, the user, the funds, who is redeemer, that is you user, what's the request ID, payment address, and a bunch of other information. And also we have this information here. Let's make it a bit bigger. We have this information here as well. What are the fees and so forth. Bunch of information which is provided to you. And yeah, you developers, you need to decide what information you are showing to the user, but you need to, the most important would be request ID and payment reference, because this is how you can reference XRP payment on XRP ledger, that this payment has happened. And let's scroll down to Flare data connector part. Yeah, here we have the redeem contract, and that is using redeem functionality from the WAGMI. So, and that is using redeem function. So once again, if you type wrongly this, it immediately tells the function name is not correct. And here we need to pass as arguments lots, XRP address where we want to redeem to, and executor. And remember, we are not using this executor in this example, but if you are a wallet developer, then that would be very important, because you can act as safeguard for your user, so you can observe in this time 15-minute time frame this payment has happened. So user don't need to worry, so they can leave to that to executor and pay a small fee to do that. But that is up to you developers decide how you build your infrastructure. But this is why we have executors in FAsset system. And the important stuff is here. So how we are processing the attestation. So we fill all the information. What's the deadline block number, deadline timestamp, and yeah, so that is very important we calculate that, and all of that is yeah, that is here how we calculate what's the information. But basically, this information comes from operational parameters. So that is the 50-minute window. So how many seconds has the agent to pay the underlying fund? And here is a bunch of Flare data connector things, which I will not cover in this demo. So yeah, so once the window has passed, we can go ahead. If we haven't received funds, then we go and make the ask the FDC, hey, prove that this payment has not happened. And with that proof, we can go back to FAssets system and tell, hey, I didn't receive my payment. I want to get my funds back using agent collateral. So that is it today. And yeah, like I know it's a lot of content, but we have this this demo code in our GitHub, and you can go and check later and slower if you want. But let's finish our presentation. So in summary, what we checked today. So in essence, we checked cross-chain XRP to FXRP operation application. You have XRP, you want to get FXRP representation on Flare chain, you want to use it in smart contracts, that is minting. Then FXRP is ERC20 token. You can build any type of applications on top of ERC20 token. Once you want to get back your XRP, you use redemption process, you get back your original asset, which is XRP. Also, we briefly checked Flare data connector attestation system. In this demo, there are a bunch of other attestation types, but in this demo, we checked payment proof that payment on XRP has happened, and also that payment in specific time frame with this specific reference has not happened. So those two we look today. And very important, it is using developer tooling behind the scenes or Flare periphery packages, which are node packages or also distributed to Foundry for Rust as Soldier package. And that holds all the smart contracts, artifacts that you can build any type of types you would like. In this example, we used VM developer tooling to build these WAGMI hooks and TypeScript types for type safety in code editor. And here are links. Don't worry, we have this presentation later available for you. So these two links, the demo application code, and all the other developer resources are on our DevHub. Here are QR codes to our DevHub, Twitter account, Discord. Ask if you have any questions on our Twitter, Discord, or whatever platform is more convenient. And me or my team will try to help you, you developers, builders, how to build on with Flare. And now we open room for Q&A. Here is finally the QR code that you can scan you can fill. You don't worry, you don't need to fill right now. Just take a photo, scan it, and you can get this very nice merge sent to you. And leaving this QR code. If there are any questions, then I will be happy to answer. And yeah, like happy building with FAssets. And if you are shy now or look at this recording later, reach out to me or my team and ask any questions you have. And all the materials, remember, are in our Dev Hub. So I would leave that due. I know it was a lot of content, a lot to take in mind. But yeah, FAsset is safeguarded with all these protocols, and it needs to be very secure for our users. So that's it from me today. And if you have any questions, then write them. If not, I know it's a lot of content, then we can finish off and see you in next episodes.